it, since what I would like to achieve was a kind of a 3D surface. So the idea was exactly this. There are wonderful software um, add-ons, let's call them, for Blender. For example, Tiny Ice is one of the most wonderful shader I've seen for creating ice, but my aim was different, since what I would like to do was to recreate the 3D structure of the iris, and that was quite complicated. So, because first of all, I needed to understand in some way the main features that I needed to reproduce. And another thing that I wanted to achieve was to have something that I can animate. So, for example, this eye, I just can change the different features. So, for example, the eye, the pupil diameter, and everything will move accordingly and in a current way. So, first of all, let's see uh, what we need to reproduce. So, first of all, for example, this is a session of an iris. As you can see, it's not at all flat. There are different kind of let's call them prominence that you have, and so I wanted something that could replicate a personal profile in the iris. So I recreate an iris. Then another thing that was quite interesting is that I found an article that showed that, for example, eyes can be divided in quadrant, and depending on some feature that you can find in the different quadrant, you have, for example, different kind of DNA heritage, let's call like this. So it was an article that I found in Science Direct. So another possibility that I wanted was to create only quadrant, or to just not recreate the whole eye, but just a part of that. The other thing was to recreate all the features that are, let's say, the main feature of the eye. So first of all, we need to be quite to know exactly, for example, the limits of the pupillary circle. This one is called collarette circle. Then we have a peripheral circle and what is called the limbal circle. It's interesting also, for example, that if you have a limbal circle, which is a very marked one, it depends also on the age. And so you can have something which is more defined or less defined. And other feature that you would like probably to reproduce are this one. So the most important are the most important, I mean, just to recognize the shape, are the Fuchs scripts. There are this kind of tier in let's say in this membrane, where you can find all these stripes that we can call fibrils of collagen. And it was not easy to understand how to reproduce this one, because it's in 3D. The collarette, the Fuchs scripts can be in different Z depth. So we have Fuchs scripts in different layer, and so that was quite complicated too. Then we have Wolfing nodules. Not all the eye has them, and especially you see them in the very light eye. And we have sometimes pigment spot, which are different from the Wolfing nodules, since are less circular and are a kind of navy that you have in your iris, so it's a pigmented one. And then you have, for example, some kind of features can represent problems. For example, these are let's say normal contraction furrows, and these are a kind of melanosis if you have these kind of furrows. So that's quite interesting to know and to understand. About the Wolfing nodules, you see you can have zero, or you can have some of them in different quadrant, or a lot of them in all the eye. Another macro feature that it's quite difficult to, let's say, to reproduce is that, for example, uh, dark eyes, the macro aspect is totally different from the, um, the light one. Apart that, there is also different kind of it's called it's a, let's say, classification of the color of the eye. So you have this one, which are light blue or gray, then you have blue or green, hazel one, dark brown, and brownish black. I have to say, for example, my eye are mainly brownish black, so very dark. And what is the different aspect that you have? Let's see a macro, for example. This one, it's a more dark one. You see that the difference is that instead of having this fibril, which can be seen, we can distinguish them, in a dark eye it's difficult, because you have here all the fibrils merge. Actually, they are not the fibrils that merge, but you have a pigmented stratus. So you have other kind of cell, I think they are called astrocytes, and so you don't see anymore this division. So it's very important, this one, because on the even without coloring your eye, you know that some kind of dark brownish dark eye will have some kind of feature that, for example, you don't have in the light blue gray, and vice versa. So before coloring your eye, it's important to know the shape that you will have. And as you've seen, for example, for Wolfing nodules, etc., one thing that I really don't like is it was that sometimes you find this feature very randomly, not where they have to be. I mean, for example, sometimes people over exaggerate with the Fuchs scripts, and they want a lot of them, and but there are too many of them. I mean, generally an eye is not like that. This eye, for example, that I represented can be a quite brownish eye, because you see here that you don't see a lot the fibrils, and I created this one especially to show you. In just in a moment we will see what kind of let's say what kind of trick I use to create this one. But as you can see here, also it was quite difficult for the eye, the light one, let's say, because you have I found that you can just split in 3 different zones this kind of fibril, and they are in some way more wavy or fuzzy, while at the beginning they are not. Another thing which is not about, or at least I didn't find in any anatomy book, was about, as you can see here, if we think this fibril is like hair, we have just a group of hair, and so sometimes there are 3, 4. They all started from this part, which are the furrows. These are the furrows, which is the limit of your iris. And that was difficult, since I had at first an approach where I tried to create just a few of them, then replicate them, then to create all of them. Then another approach was just to deform them after creating all of them. So that was different kind of trials that I made, and they have all an idea on the background. For example, if you see the first shader were just a strip that was then circularly replicated, and so that was an idea first, so try to create a few of them and then replicate, but that didn't work for realism, since I didn't succeed in creating the features. So now let's see what are these nodes that I hope can help you in creating this kind of let's say eyes. So first of all, what I wanted to do, for example, was to have total control on the fibril. And as you can see here, I have both control in the XY position and also in the longitudinal section. So I can create using just these two, I don't know how to say, but this widget, I don't know what they are, but I can just change them, and I can change the sections, so all of the section. we start having, let's see now, let's do something like this. I select this one, it's the final one. And so I'll get rid of all of them, and I will show you one by one what the nodes do. So you can select them, and you can then combine in the different, however you want. I've put also some kind of here just a switch, so you can choose what you would like to see or not in your eyes. So first of all, we have here this one. We need to we want the switch, for example, for this one. This is just a base, dark base gray that you have there, and then you have, for example, if you need to use the just if you want to know limit, you have here your limbal circle that you can create, just so things that are very easy to recreate. This one is for creating some kind of spot, so you can go here and just again, so spot will create just as you can see here, just a random stuff that you can also increase the subdivision. You can increase the subdivision for looking at the spot that will get projected. And so for Fibrils, the idea is it's quite easy. So this is the, let's say, probably the biggest one node that you can replicate, and you can create layers and layers of Fibril. As you can see here, for example, I created at least 2 or 3 Fibrils. What you can do is just to choose the Fibril section. So it's just a tube, and you can just choose how many of these how much the resolution of the tube should be. I suggested to leave the sample, the longitudinal one, so to have 24 that you can just create and adjust. And now I will do like this. So I will just take one Fibril and show you just this one, for example. Okay, so let's see if everything, and we get rid of the other one. Okay, so let's take a node, for example. Let's say that you want to create just one Fibril. Generally I work in the other just with 2 monitors, so that's why this one looks so small, but the idea is just working with 2 monitors, or better, you will see just everything not so compressed, and you can navigate better. So let's see, cut Fibrils, raycast. Okay, this is another stuff. Merge the clip. I tried to document everything, but of course it's a bit complicated. And then so let's see in the viewer. So this one, for example, oops, sorry. This one, for example, I have here in the viewer is one strata of fibers, and Fibrils, let's call them more just exactly. So here are the Fibrils, and you can see here these are the how many samples you want here, and you can flip also them if you need just to have something worse to create another strata, and that's okay. Then you have a minimum thickness and a maximum one. So you have a range. You can put a range so to have all of them with a variation. Then you can choose, for example, the ratio between the noisy and the fuzziness. So let's say that you want the first part to be quite calm, not fuzz. So you can just divide the dimension, so this section, in different proportion. So for example 1 to 1, or you can choose 1 1 1, or whatever you want. I mean, so this, you need to keep in mind that these are the proportion of this section, so from the center of the pupil to the limbal, and you can subdivide as much as you want. For example, it's generally not so common to have very fuzzy this kind of fibril starting from the pupil, but you have something which is quite flat. Then you have the center, which is a bit wavy, but not too wavy, not too much. And the other thing is that you have the border generally are more fuzzy. So having a look a lot of this fibril, probably you can say, oh, okay, but it seems that there are some kind of trees or L system. Actually, I tried also with L system, but if you have a close look, generally you have different stratus of the fibrils that intervene with each other, but it's not like a tree. You don't have at the end a lot of them, probably you have one or two you see, but you can just replicate this kind of stuff just using just interweaving different layers. So that's the idea. So the other thing, it's I mean, after you create fibrils, what you need to do is just to cut them and to project on them, for example, crypts. For doing this one, I used the ray casting, and it was quite easy to do it after you understand how. And that was not so immediate at the beginning. And you have here, so for example, a node for creating crypts, so this kind of cut, and they are created just creating polygons that you can then these polygons, they are used to be projected on the fibrils and to cast their holes. So I didn't use Boolean because Boolean made everything a bit crazy, and it was not so responsive, it was not so fast. Cutting fibrils was not okay, and so it was not easy to understand how to recreate. But the best thing also to have something which was realistic and manageable was to do this kind of stuff. So to create something like you can see here, that also this one are procedural. So the funny stuff is that the more you put, they will just arrange the dimension automatically that you want. So you can also add a kind of fuzziness also here. And then after you create this kind of holes, you can project them directly on here. This, for example, it's with geometry proximity. It's the project the crypts on the fibrils. Another thing that I like it to do, and it was a bit crazy to do and difficult, is after you merge the fibril and the crypts, to create some kind of magnets that can distort the fibers that you have. So it again use proximity, and but I needed a bit of tweak in order to make it fast and usable, because otherwise it was quite crazy. I tried different stuff. For example, I've tried some kind of simulation in order to put there the creeps and make the strands or fibrils to avoid them, but it was not so easy because the simulation were not I couldn't change, for example, like a real eye with the simulation, since because each time they needed to calculate where these scripts were. So finally the best thing was to create something like this. And the funny part, so my computer here, it's a bit slow, but you see that, for example, if I change the pupils, for example, now I put the maximum that you can have in an eye is maximum dilation. I think it's 0.6 or 7, not anymore. An eye, it's 1.7 centimeters. So 1.2 centimeters. So you see that here, if I change the dimension of the iris, everything, including the creeps, will change according. So everything that you can see here in this eye procedural, everything. The only thing that you can do manually is just to change the profile of the fibrils if you want, or just you can leave as them and add just a bit of noise. And yeah, I think this is almost all. we've seen that you can divide the root, the fibril, the sample here, the furrows also you can put. So furrows are this small stuff. You can also change this one, choose the number, how much of them you want, and of the number here of the fibrils that I put just I think it's for I put just 256 are almost, so for each layer you can just set them when you change the resolution of the instances of the fibrils. You see, for example, that for this eye I have 3 stratus of fibrils, I have 3 stratus of different creeps, and I also have I also finally merged them for creating the eye, like the one that the dark brown eye. So what we do is also to create here an SDF, so a mesh to SDF grid, a grid to mesh, and then so shade smooth. If you, for example, if I get rid of this, you see that yeah, so for example this one are just the fibrils without the other strata, and so you can just selectively get rid of different stratus to see how this work. And I like it a lot, the raycasting, so I leave it, I use Eve for example for this one. I just made a very quick try if you can apply a shader, and that looked okay. And so I'm very glad to share this with you, and hopefully you will create a good image that you would like to share. And one of the idea was also to create a simulation, for example, since you can animate and randomize everything, simulation of the different kind of iris. And for example, you can use it for training some kind of neural network to just see if I mean, whatever you do with just training, the idea is that here you can create a lot of images very fast and with a lot of different features. And so yes, that is an idea that I want to see. So this was just a comment on the file. I probably prepare also some tutorial, I don't know when, but I think it was the moment just to share everything and not keeping that in let's say in a drawer, and just to let this file be free. Thank you for your attention, and I hope to have feedback from you.